In our last video, we dealt with spanning tree protocol, and we saw how you can use a redundant switch network at the same time having a layer 2 loop prevention mechanism. In this video, we are going to look at rapid spanning tree protocol. So before we dive into the configurations, we're going to see some of the disadvantages of STP in terms of speed. So if you don't have basic concept of STP, please check our previous video on STP. Okay, so in this switch topology, we have 3 switches, and switch 2 is currently the root bridge. That means it's a switch with the lowest bridge ID. Okay, so now communication from PC2 to PC1 is actually going to go through switch 2 and down to switch 1 and finally to PC1. So because at the moment switch 1 is blocking FA0/23, so that means the traffic is expected to be forwarded through this link. So now to test the delay that STP sometimes can incur, we are going to test continuous ping from PC2 to PC1, and we're also going to do some triggers, changes on the network. So normally if a link fails, STP recalculates the STP links, which links are going to be used as root bridge. They start to check. Remember, we said redundancy is actually an alternative path. For example, if this link is down, because at the moment switch 3 is selecting this G0/1 as this root port, you can see that if you see the command source spanning 3, that G0/1 is a root port. But if that link is no more available or it fails, so it's going to switch to the other available links. So that triggers changes, and STP is going to do recalculations. So, but in that process, STP takes a lot of time. So you see, I recommend you to watch our previous video on STP, where you can see the port will be changing from block mode to listening mode, learning, and before it goes to forwarding, it will be like 60 seconds. So in modern networks, whereby there are a lot of things running in the network like videos, communication, voice over IP, there could not be tolerance of this delay, huge delay in the network, because you don't want to be speaking on the phone and have to wait for 2 minutes for your response to come up, because voice cannot tolerate delay. So we're going to ping from PC2 to PC1, and after we're going to trigger some changes and see how STP is going to take long to recalculate and switch over to other links. Okay, so we're going to ping from PC2 to PC1 with the IP 10.0.99.1. Okay, so this ping is replying fine, and at the moment no packet drop because network is good, it's working fine. So let's trigger some changes. So we know that this switch 2 is the root bridge. So now we're going to force switch 1 to become the root bridge. Okay, so we know that the root bridge selections is based on the bridge ID. So we are going to now force this one to become the root bridge by giving it a lower bridge ID, that is a lower priority number. We said spanning 3 VLAN 1 root, and we give it a priority. So we can say root primary, or if you want, we can give it a priority VLAN 1 priority. The priority has to be in numbers with the increment of 4096. So here we're going to take 8192. So this is going to force switch number 1 to become the root bridge. As you can see, now this was the root port in switch number 3, but now it is changing. So if you go to PC1 or PC number 2, you can see that the ping has started dropping. So because this while at this moment, so STP is trying to recalculate, and you can see G0/1 is now on block mode, and before it was on forwarding mode. So STP is trying to do recalculation and figure out which way is the best path. So here you can see the link is back up. So that means because that's use of redundancy, but almost 1, 2, 3, 4, 5 packets have been lost, and that can be in the time of from 10 to 60 seconds. So now switch number 1 is the root bridge. So traffic is going from PC2 to PC1 via switch 3 and straight to switch number 1. As you can see, FA0/23 is no more in blocking mode, but now it's in forwarding mode. So now switch number 1 is the root bridge. So this downtime, because of STP is recalculating the best path, sometimes need to be faster, and we can get that to be faster by using rapid spanning tree, so that even if a link failure happens in the network or a changes occur, so the normal users will not realize that something went wrong in the network. So they should not realize that, oh, there was a link failure. So if somebody was talking on the phone or if somebody was on video conferencing, they should not realize that there was an STP link changes. So this switching over should go just within some few seconds. Okay, so now let's dive deeper into the rapid spanning tree configuration and see. So to start with, we're going to go into switches, and now we enable the spanning tree mode. If you look at it at the moment, it says show spanning tree summary. So here we can see that this switch is in per-VLAN spanning tree mode. So that is actually what it is using. So we have to switch to rapid spanning tree. We go to global configuration mode and say spanning tree mode rapid per-VLAN spanning tree and enter. So this will now change from normal per-VLAN spanning tree to rapid spanning tree mode. So show spanning tree again summary, and now we can see that it's saying the switch is now in rapid per-VLAN spanning tree. Okay, so the next thing is we actually configure this interface FA0/9 going to switch PC1 as a port fast. So if you're running rapid spanning tree, so those interfaces that are going to end devices should be on port fast. Interface FA0/9 spanning tree port spanning tree port fast enable. So here you can see it's giving us a warning that okay, port fast has been configured on FA0/9, but will only have effect when the interface is in non-trunking mode. So that means port fast should only be enabled on ports connected to a single host. So that means connecting hubs or concentrator switches. These are not interface to be enabled. So that means if interface is connecting to switches, for example, the trunk links should not be enabled with port fast. So port fast need only to be enabled on the interface that are connecting, like servers, your computers and the like. All right. So we move to the next device and we configure spanning tree, rapid spanning tree mode, rapid, enter. So that one is done simply because this switch has no PC connected to it. So that's the only thing we need to do there. So we jump to switch number 3, spanning tree mode, rapid. And the next thing we configure the FA0/9, the spanning tree. Sorry, I just mistake this thing. I switch port spanning tree, port fast, enable. So here also we are done here. All right. Okay, so we will now try to initiate another ping from PC2 to PC1 and also trigger a changes and see how the switch over is going to take place. Okay, so let's initiate that ping again from PC2 to PC1, ping 10.0.99.1. Right, a continuous ping there. So note that at the moment switch 1 is acting as running as a root bridge because it has a lower priority. Okay, we can display that by using the command show spanning tree, and we can see this bridge is the root because it has a priority of 8193. That was 8192 that we configured plus the VLAN ID 1 that give it 8193. So we are going to force again switch number 2 to become the root bridge again. So that will trigger some changes, and we can see how that changes will be recalculated by rapid spanning tree and whether it's going to take little time than STP or not. So now we are going to configure switch number 2 with a lower priority. So remember we said the priority has to be increment of 4096. So we go here and we said spanning tree VLAN 1 priority 4096. Okay, so before I effect the changes, so know that our ping is going smoothly, but immediately that changes is effected, so STP will start the calculation again. Rapid spanning tree this time. So see the ping that is coming from PC2 to PC1. So know that one packet has been lost because rapid spanning tree is going to do recalculation again. So you see, it is back on. So it's just 2 packets that we are lost, and RSTP has recalculated and finished. So now switch 2 is the root bridge, and traffic is no more going direct from switch 3 to switch 1, but it's going via switch 2 and to switch 1 and to PC number 1. Okay, so you can see rapid spanning tree is much more faster than spanning tree, because spanning tree takes longer. So in RSTP, all the calculation from block mode to forwarding mode takes less than 15 seconds, or within that range. Okay, so if you can see, if it is an STP, it will take up to 60 seconds. All right. So another important thing about Per-VLAN spanning tree is to have your root bridges decentralized on the switch network. So as right now we have this switch, currently the root bridge for VLAN 1. So we can also have other switches to be the root bridge for other VLANs. Okay, so here, if I say so spanning tree VLAN 1, we can see that this bridge is 0. So, but there are other VLANs, like if I display the VLAN, we can have VLAN 1000 and VLAN 200. So let me make switch number 3 the root bridge for VLAN 100. So I will just go to global configuration mode and say spanning tree VLAN 100 priority. I can set 4096. So this is going to make sure that this switch will be the root bridge for VLAN 100. So if I want, I can make also this one as the secondary root bridge for VLAN 200, and so on and so forth. So that in that way, you don't want to put all of your eggs in one basket, or you don't want to make sure that one switch is overloaded as a root bridge and all traffic will be passing through it. So right, so that is rapid spanning tree. So it's easy to configure. You just need to change the mode and enable the interfaces connecting to computers as port fast. So that should keep your switch network in a redundant form, as well as speed up recalculation of spanning tree in the event that link changes occur in the network. So if you enjoyed the video, please subscribe, and I will see you in the next one.